Thank you, Sue, and hello everyone. So I'm going to be talking about the problems with something that I really love. I really like observational data, but it does raise some issues and we need to be aware of those issues. So what do I mean by observational data? Well, most big data is observational data. It's bank records and social media. It's data that's out there. It wasn't collected for our purpose, but we can look at it and we can use it. It's about real behavior. Sometimes that data is a census and sometimes it's a sample. So it might be all phones. If we are getting data from a telco about cell tower usage within a city, it will be all mobile phone usage within that city. Sometimes it will be a sample, those people who have downloaded a particular app onto their phone, for example. Sometimes the data is substantially objective. It is receipts, it is bank transfers. Other times that data is subjective. It's ethnography. It's sitting in a usability testing, looking at somebody having a problem. Both of those are observational, but they're obviously quite different. It can be structured or unstructured. So again, we have the phone records, the bank records, very structured, or it could be all those photos, videos, and images uploaded to social media, very unstructured. It could be about behavior, or it could be observations relating to motivation. So loyalty card data is about behavior. Facial coding and other biometrics are observational data that are seeking to look at the motivations. It might be naturally occurring. So again, if we take the bank records, the loyalty cards, all of that data is happening. Or it might be experimental. We may change a particular store, look at how people behave and shop, change the store again, look at how they behave and shop. So we've got an experimental design. Or we can also use observational data in combinations with questions. So we might do an ad test and use biometrics to get additional information. We might do a usability test where we've got some survey questions, but we've also got some observational data being collected. And why have we had this big change? So it primarily used to be the case that market research was about surveys and focus groups and depth interviews. And we are moving really substantially towards observational data. Well, the first is the realization, the increased realization that the limitations of asking. The behavioral economics, the neuroscience has told us that in many situations, we are very bad witnesses to our own intentions, our own motivations, our own plans. The second is that, as Brian has just talked about, it's getting harder and harder to get good survey questions with a good response rate to people with a good representation of the whole population. So there are problems with questions, and then there are problems with achieving questions. Thirdly, there is just so much more observational data available. Because of the digital world, we are leaving this wake behind us of information. As we go out, we're using our smartphones, we're browsing the internet, we're using ATMs, we're paying with electronic devices, we're traveling with Uber, and there is this immense wake of information. And of course, that is a tool that is now available, and we want to use it. We've got the increased processing power with cloud-based systems, which means we can process this observational data, and we have more AI tools that allow us to use that increased processing power. And sometimes it means we can move from a sample to a census, and that has got a lot of face validity. It actually may be no better in terms of information to move from a sample of 1,000 to the entire customer database, but it feels a lot better. People feel a lot happier about using that information. But all of those benefits, and they are tremendous benefits, create some problems, a house of cards if we're not careful. And what I'm going to do is very quickly highlight just a few of the examples of these problems to make sure that we all think about using observational data more carefully. The first is really well known, Spurious Correlations. This website from Tyler Vigen consists of nothing but spurious correlations. Trawls the internet, finds these data. So worldwide non-commercial space launches correlates really closely with sociology doctorates. No, it doesn't. That is just an accident. If you have enough data, there will be more and more accidents. Nate Silver, who is perhaps the best known commentator in the big data and the data science sort of area, has made the point that as the amount of data increases, we'll get an exponential increase in false readings and a linear increase in true readings. The true readings will become a smaller and smaller percentage of things that are in the data. So we need to really be looking out for spurious correlations. The next one is where the observational data itself has some really strong underlying bias. And this goes back, this particular New York Times article, to 2003, where they were looking at hormone replacement therapies, HRT, in the United States, where they'd had to halt a trial because it was quite obvious that what they were doing was actually leading to bad health outcomes. So when HRT was first assessed, it was assessed with a thing called the Nurses' Health Study, a really large observational study in the United States. It seemed to be protecting women's hearts. So doctors were recommended to prescribe it more widely. So as well as dealing with menopausal related issues, it also seemed to be conveying some health protection in terms of cardiac problems. The Women's Health Initiative, which is a gold standard controlled experiment, double blind, some women were given the HRT for real, some were not. They didn't know who was getting it, the doctors didn't know who was getting it, and that suggested that it was slightly bad for the heart. Wow, the massive observational data said it was good, but a proper experiment suggested that it was bad. Why? The women receiving HRT were systematically healthier and wealthier. They had better health outcomes than the population. So there was an underlying bias in who was being given this. And every time we look at observational data, we need to think about, is there an underlying bias causing this outcome? This is a simplified version of a chart I saw a few months ago in the UK. Chief marketing officer from one of the large fast-moving consumer goods, the CPG companies, came along, and he was talking about ice cream sales. And his marketing person in charge of social media came along and sort of banged the table and said, it's a disgrace that we're not spending more on social media. Look at this chart. The blue lines, the blue blocks, are the social media spend. And the dark line, the black line, is the sales. When we put up the social media spend, we get more sales. When we bring down the spend on social media, the sales fall off. Why are we cutting the spend? We should be spending more and more on social media. And the CMO, who has been in the industry a long time, just scribbled onto the chart the following pictures and said, you know what? We sell more ice cream in the summer and we sell less ice cream in the winter. And that drives ice cream sales, and that also drives social media advertising. We use the social media advertising to compete with other brands. We are not going to make people start wanting ice cream in the winter by spending a little bit more on social media. Which brings us to a really important concept. Whenever we're using observational data to look at campaigns and activities and programs, then we need to think about the counterfactual. What would have happened anyway? It's not enough to show there has been a change. You have to show that that change is different to what would have happened. So the counterfactual in this case is that sales of ice creams in the winter are low, sales of ice cream in the summer are high. Can we beat the counterfactual? Can we change what would have happened anyway? The next category is where we've got observational data, but it's throwing up measurement error. And this was a great example presented last year in Lisbon from some German researchers. There's been a long-standing travel study in Germany, and people tended to use a paper diary or electronic diary to write down all their journeys. So it was memory-based, and we know what the problem is. You forget to write down all of your journeys. So they thought to themselves, well, can't we move it forward? So they did a trial with mobiles, automatically capturing information. So they got these people to download an app, it recorded when they moved, and then people were prompted to add the additional details of why did you make this journey and did you travel with somebody else and so on. But the actual journeys were being recorded automatically. And there were some real benefits. There was less heaping of the distances and times. Now, heaping is where I say I traveled 1 kilometer, or I traveled 2 kilometers, I traveled 3 kilometers, and nobody is traveling 1.5 kilometers. Nobody's traveling 1.7 kilometers. Heaping the times is, oh, it took half an hour, it took 45 minutes, it took an hour. Nobody's taking 57 minutes or 56 minutes. So we get better granularity, a better distribution of times when we use the app. But it recorded 16% fewer journeys. They expected it to record more journeys. They thought sometimes people would forget to use the diary. So if we use the automatic system, it's surely going to generate more. Also, 11% less distance was traveled, 18% fewer minutes were recorded. This was bad, and they looked into what was happening. And the key reason, obviously sometimes people didn't take their phone with them, but that was a pretty small reason. The key reason was that because of German law and because of sensibilities, the app turned itself off when people's phones batteries reached 20%. And it turns out a lot of people have their phone battery down around the 20% mark quite a lot of the time. So this was a fairly fundamental problem for them in doing that. Now they're looking at some methods going forward, but you can see how this measurement error has really changed the nature of the observational data they were collecting. One of the issues that people always talk about, it's probably market researchers' favorite topic when we talk about observational data or big data, is explaining the why. And this is a fantastic TEDx video. If you search for it, Ben Wellington, TEDx, you're going to find out 10-14 minutes of fantastic examples of finding open source data and using it to tell a story. And one of the stories he talks about in this presentation is about fire hydrant parking fines in Manhattan. And he charts it, the bigger the circle, the higher the fines. And he says, well, okay, we can see what's going on the Upper East Side, masses of hydrants, masses of fines. We can say pretty confidently it's not a good idea to park in the Upper East Side. You're likely to get a fine. But then he spots 2 hydrants in the Lower East Side. They are the 2 hydrants that generate the most money in the whole of Manhattan. They generate over $55,000 a year in fines. So he said, well, why are they doing that? And do you know how he found out? He went there and he had a look at it. That is what we call qualitative research. He went and he had a look and he inspected it, looked at it on a one-to-one basis. And what was happening is the fire hydrant there has got a circle around it. Then there's what they call a curb extension, which is used by cyclists. And then there is a parking spot that is painted. Now, if that curb extension was a designated cycleway, those cars would be legal. But it's not a designated one, it's just one that is used by cyclists. So the NYPD, the New York Police Force, came along and they kept ticketing cars in there. He reported this and the painting on the road was changed to make it conform. But that is beautiful. This is showing how you get something in the data that produces something interesting, observationally sound, but then you need to do something else, some research, and in this case, qualitative research, and it tells you what the problem is, the why. We have observer effects. Watching, measuring behavior can change behavior. So one of the nice examples of this are the speed cameras. The RAC study of speed cameras in 2013 in the UK found a 27% reduction in fatal and serious collisions in the areas around speed cameras. Now, nobody before the speed camera was there was deliberately doing things that made the likelihood of a crash more. But when they saw they were being measured, they changed their behavior. The change in behavior led to a 27% reduction in fatal serious conditions. So if we ask people to take photos of other people, then we may change the behavior. If we know that your spending is going to be monitored, if we know that your Facebook likes and behavior is going to be monitored, it may change the behavior. This one is really scary. This is an investigation into why the Space Shuttle Challenger crashed. When they looked at all the wreckage, they discovered that these rubber things, these O-rings that were part of the composition, had failed. And they wanted to look into why it had failed and why it had not been discovered that they would fail. And it turned out that cold was a real problem. And they took this chart, the Presidential Commission investigating it, from the records at NASA, and said, okay, this is kind of what they thought the problem was. They did a chart here which shows all the O-ring failures that had happened previously, and this is in degrees Fahrenheit. So we see that there were 2 failures at 75 degrees Fahrenheit. There were 2 separate failures, 41D and STS2, which would be the locations, I guess, at 70 degrees. And there were some failures at about 57 degrees. And there was 1 failure at about 3 failures of the same joint at about 53 degrees. So there's no pattern. Temperature, the air temperature does not seem to matter in terms of the O-ring failures. What we've done is we've taken all of the failures and we've looked at their distribution over temperature. But what the Presidential Commission did was it looked at all of the recordings, not all of the failures. And that showed that when the air temperature was above 65 degrees Fahrenheit, there were almost no failures. There were some failures, there were 4, but not many. It was normally fine, no failures. Below 65 degrees Fahrenheit, which is quite rare where they were launching the shuttle, there was always an incident with the O-ring. So this is what we call survivor bias. When you just look at the outcomes and you don't look at the inputs, you can get a really wrong reading. When they only looked at the failures, they thought temperature didn't matter. When you look at all the successes and the failures, you see temperature matters enormously at somewhere around 65 degrees Fahrenheit. And that led to the loss of life of the whole crew of the Challenger shuttle. Another survival bias, but flipping it around this time. So instead of looking at failures, we look at successes. This was a really popular book by Tom Peters, In Search of Excellence. And what he did was a fairly traditional way. He took a look at a bunch of successful companies to see what they've got in common. And from that, he created a set of recommendations. But after just a few years, many of these companies were failing because the things they had in common weren't necessarily the reason why they were successful. To measure drivers, you've got to look at failure and success. So he should have been looking at, here's a bunch of successful companies, here's a bunch of failing companies. And failing and successful have both got these things in common, so these are not key. But actually the successful ones have this and the unsuccessful ones do not. And the unsuccessful ones have this and the successful ones do not. You need to look at both to avoid survival bias. We need to utilize experiments. Now you'll see a lot of use these days about programmatic advertising. You'll see a lot of attributional modeling, MMM modeling, market mix modeling, to try to understand how a campaign works. And here is a simplified example from some work that I did a couple of years ago with the IPA when we were producing some guidance on measuring social media campaigns. And imagine that in region 1, in time period 1, let's call it January, sales were indexed at 100. And in time period 2, let's say February, we run a TV campaign and the sales go to 110. And then in time period 3, we run a campaign which is TV and Twitter and the sales go to 130. What do we think has happened? We think that Twitter has added 20. That Twitter is really powerful because we can see the sequence. It's an experimental design. However, in region B, we ran the design slightly differently. So time period 1, January, no campaign, sales indexed at 100. Time period 2, we ran Twitter and sales went up to 110. And in time period 3, March, we ran TV and Twitter and the sales went to 130. Now we get a different inference. Now we say there's a combinatorial effect. When you run TV and Twitter, it's more than just the addition of the two pieces. And so it's not that Twitter adds 20, it's that combining TV and Twitter adds 20. But in region C, we looked for the counterfactual. What would happen if we didn't run any campaign at all? And in T1, it's indexed at 100. In T2, as the weather may be improved, it went to 105. And in T3, it went to 110. So when we look at regions A and B, we have to deduct what would have happened anyway. So we can use observational data, but we probably want to build experiments into it. Now, when you're talking to the advertising companies, the marketing companies, they often want a big bang. They want to start everything on the same day and they want to go out there really strongly. But if we want to measure the effects, we actually want different regions, different groups. We want to be able to tag people within the social media world with different characteristics so that they will see a different sequence so that we can measure those observational effects. This is a wonderful example from just last week at the SMR conference in APAC. Brent Smart, who is the CMO of IAG, an Australian insurance company, showed the result of an experiment that his company had run. 19 weeks of retargeting experimental data. They did a standard attribution model and it said that the advertising had worked really well. They did an algorithmic attribution model. It said the advertising had worked really well, but actually they'd conducted an experiment. They had shown the advertising to some people, they had not shown it to other people. They measured the sales result and there was no impact. Minus 26 is the same as no impact in terms of confidence levels. So there was a pure artifact of not having the right design going into the standard attribution or the algorithmic attribution model. We absolutely need to bake experimentation into the activities we do so that we can measure that observational data. We also need to think about the ethics of observational data. And there's some really, really useful studies out there, in particular this health one. So, recommendations. Talk to experts about designing and interpreting the data. Make predictions so you know whether you're right or wrong. Identify the counterfactual. Build experiments. Look for other causal patterns and explanations in the information. And of course, add explanatory research, for example, qual. Thank you very much, and I look forward to questions.